This is number 29, chapter 5. I've drawn the picture. So we have a box connected with the rope. We can call that tension in the rope. Another box that it's going to be pushing. Third box, and then some applied force. There's no friction in this situation. It's a 1 kilogram, 2 kilogram, and 3 kilogram box. So this is a system. So let's analyze the system as a whole. So we're going to do an F equals ma for the system, and when we say F equals ma, we always mean some net force acting on the system. So there's some applied force, and that's really it. Since there's no friction, there's no actual force that's opposing the motion here. There's gravity acting on these three things, but it doesn't really oppose the motion, and there's corresponding normal forces that balance those out in the vertical direction. So, I guess technically we are looking in the x direction. So there's some applied force, and then what it's doing is accelerating the entire mass of our system at a certain value. And so if we put those in, we get 42 as our applied force, and then we get 1 plus 2 plus 3 to cause some acceleration, and that acceleration ends up just being 7 meters per second squared. Okay? If we look then, let's say we just look at, say, the first two blocks. So the first two blocks. We could do F equals ma. Well, the first two blocks are being accelerated by some tension, and the first two blocks have m1 plus m2 times some a. Well, we don't know what the tension is, but I know the sum of their masses is just 3, and we know they're accelerating at 7. So that must mean that the tension in the rope is 21 newtons. Okay? Let's look just at this block. Okay? So we'll call that the third block. The third block, if we looked at it, we did an F equals ma for it. It's got an applied force. It's got a tension going the other direction, and then it's just got its own mass times an acceleration. Okay, so this is 42 minus t equals its mass of 3 times 7. And so if we solve for the tension, we'd get 21 newtons. And we're like, huh, imagine that. These match. Of course they do. The tension pulling these two blocks is the same as the tension pulling against that block. So this was an unnecessary step. I just wanted to show that those things are the same. Okay? If we wanted to find the contact force, right? So how hard is F1 pushing on box 2? Then we could just look at box 2. So just the second block. Well, the only thing making it move is F1, 2. And what's it doing? Well, F1, 2 is pushing a 2 kilogram, 7 meters per second, and you get 14 newtons. So you get 14. And if you wanted to show Newton's third law, you really could then look at, well, if we just looked at the first block all by itself, tension is making it move, and F21 is pushing back on it, and that equals its mass times its acceleration. So the tension was 21. Let's pretend we don't know what F21 is, and that equals its mass of 1 times 7, and you get F21 equals 14 newtons. And again, what we've shown, Newton's third law, says that F12 and F21 have to be the same. No matter how hard block 1 is pushing on block 2 is then opposing that motion back to block 1. These are Newton's third law action-reaction type forces, and hopefully you can see they're in the opposite direction. This is to the right, and this is to the left.